Hello children, in the previous lecture I discussed some of the problems from NCERT Exemplar book, and today I will be discussing the remaining problems. So let us start with the problems from NCERT Exemplar. Question number 19. In the last lecture I discussed till question number 18. Today I will start from question number 19. So you just have your book in front of you and read the question with me. Question number 19. An object is dropped from rest at a height of 150 meter, and simultaneously another object is dropped from rest at a height of 100 meter. Means this is the height of 150 meter, and from here an object is dropped from rest, so its initial velocity is 0. There is another object at height 100 meter. It is also dropped from rest. U is equal to 0. So initial velocity of both the objects are same. They are dropped from rest, so their initial velocity are 0. One has been dropped from height 150 meter and other has been dropped from a height of 100 meter. Means we will discuss the motion of two different bodies. After then, it is written in the question, what is the difference in their heights after 2 seconds? If both the objects drop with same acceleration, how does the difference in heights vary with time? You see, same acceleration, that is acceleration due to gravity, will be acting on both the objects. So for first object, you see u is equal to 0 and initial height h1 is equal to 150 meter. For the second object, u is equal to 0 and height, initial height h1 is equal to 100 meter. So what is the difference between the two heights? Means distance between the two objects. Therefore, difference in the heights of the two objects initially, means at t is equal to 0, is delta h. Delta h means difference. This is 150 meter minus 100 meter, means 50 meter is the distance between the two objects at t is equal to 0 initially, means when they start coming down. After 2 seconds, you see at t is equal to 2 seconds, h2 is equal to formula ut plus half gt square. This is ut, u is 0, half g is 10 and t is 2, so square of 2. This will be half into 10 into 4, 2 2s are 4, means 20 meter. What does it mean? The first object has come down through 20 meter, and second object, for second object you see h2, it is ut plus half gt square. Again u is 0, half g is 10 into 2 square, this is also 20 meter. So what is the height of the two objects now? Difference in their height or heights of the first object from the ground is h2 dash, h1 dash, we take h1 dash, it is equal to, h1 dash is how much? h1 was 150, and out of 150, 20 meter it has traveled now, so minus 20, this is 130 meter. In the same way, height of the second object from the ground is h1 dash for this. This is equal to 100 minus 20, that is 80 meter. So what is the difference in the two heights now? Therefore, difference in the two heights, delta h, is equal to 130 minus 80, that is 50 meter. So what have you seen? Earlier, whenever the object were dropped, the difference in their heights was 50 meter, and after 2 seconds, the difference in their heights is again 50 meter. It means the difference in their heights will never change. Okay? And the position of the two objects after 2 seconds are also shown. One is at 130 meter from the ground and other is at 80 meter from the ground. So this is the solution for question number 19. Now let us discuss question number 20. Question number 20, you see. In question number 20, it is given an object starting from rest travels 20 meter in first 2 seconds and 160 meter in next 4 seconds. What will be the velocity after 7 seconds from the start? So let us discuss it as question number 20. You see, for first 2 seconds, you see, u is equal to 0. Use s is equal to ut plus half at square. S is given 20 meter, u is 0 into t plus half, a you don't have, and t is 2 seconds, 2 square. So this is 2a, and from here you can have a is equal to 20 by 2 means 10 meter per second square. Now see, velocity of the object after 2 seconds is given by v is equal to u plus at. This u is 0, a is 10 and t is 2. So this is 20 meter per second. Okay. Now for the next, we are talking for the next 4 seconds. So for the next 4 seconds, again you use s is equal to ut plus half at square. S is, it is given that s is now 160 meter. So this is 160 is equal to, u will be this 20 meter per second, because after 2 seconds whatever is the velocity, that will be the initial velocity for the next 4 seconds. So this is 20 into 4 plus half a into 4 square. This is 80 plus 2a, a by 2 into 16. Have you got? A by 2 into 16. After then, if you will solve this, if you will solve it, this you will get 80 plus 8a. So 8a is equal to 160 minus 80, that is 80. Therefore a is equal to 80 by 8 means 10 meter per second square. What does it mean? It means the acceleration remains same for the two different duration of time, for the first 2 seconds and for the next 4 seconds. That is, the body is in uniformly accelerated motion. So now you can find the velocity. Therefore velocity after 7 seconds is v is equal to u plus at. You see u is 0 because the object starts from rest, and a is 10, t is 7. So this is 70 meter per second. This is the final velocity after 8 seconds. Have you got final velocity after 8 seconds? After then you have question number 21. In question number 21 you have the question: using following data, draw time displacement graph for a moving object. Here you will take time along x-axis and displacement along y-axis, and you can easily draw the graph because this is so simple. You learnt how to draw the graphs earlier in physics and in mathematics also. So I will not discuss this question. This is so easy, you can do yourself. After then question number 22. An electron moving with a velocity of 5 into 10 power 4 meter per second enters into a uniform electric field and acquires a uniform acceleration of 10 power 4 meter per second square in the direction of its initial motion. So there is an electron which is moving with velocity of 5 into 10 power 4 meter per second. So this is initial velocity. Question number 22. Initial velocity means u is equal to 5 into 10 power 4 meter per second. The concept of electric field will be introduced in class 10, and in detail you will learn it in 12. And whenever it will be introduced, you will learn that whenever a charged particle enters an electric field, there is an electric force on the charged particle. And you know, whenever there will be the force, there will be an acceleration. So it doesn't mean whether you are aware about the concept of electric field or not. You just have to think here that acceleration, it is already given, acceleration is 10 power 4 meter per second square. That is, a is equal to 10 power 4 meter per second square. After then, in the direction of its initial motion. In the direction of its initial motion means acceleration is positive. So velocity will increase. If it will be in the direction opposite to the initial motion, then velocity will decrease. But here velocity will increase because the acceleration is in the direction of initial motion. First part of question is calculate the time in which the electron would acquire a velocity double of its initial velocity. So in first part you have to find time when v is equal to 2u, that is 2 into 5 into 10 power 4. This is equal to 10 power 5 meter per second. You can use the formula v is equal to u plus at. V is equal to u plus at. From here v is 10 power 5, u is 5 into 10 power 4 plus a is 10 power 4 into time is to be obtained here. So from here you see t is equal to 10 power 5. 10 power 4 is here, divided by, you can write it 10 power 4 5 plus t. So 10 power 5 by 10 power 4 minus 5, this is t. So this is 10 minus 5, that is 5 seconds. Answer is 5 seconds. I think you understand the problem. Second part, how much distance the electron would cover in this time, means you have to find the distance covered by the electron during this time. So distance can be obtained by using S is equal to ut plus half at square. You can put the value of u. U is 5 into 10 power 4 into t is 5 second plus half a is 10 power 4 into t square. T square means 5 square. And I think you can solve this to get the final answer, because this is the easy solution. You should solve it yourself. I discussed the concept related to the question. After then, we have another question. This is question number 23. Question number 23 I have. Question number 23. Obtain a relation for the distance travelled by an object moving with a uniform acceleration in the interval between 4th and 5th second. Means you have to find the relation for distance during the time interval 4th to 5th second. You know the formula for distance travelled in a given time interval. So distance in 5 second minus distance in 4 second will be the distance travelled in 4th to 5th second. No, in 4th to 5th second. So let us find the formula for that. You see question number 23. Question number 23. You have the formula S is equal to ut plus half at squared. Therefore distance travelled in 5 seconds is S1. It is equal to u into 5 plus half a into 5 squared. So this is 5u plus 25 by 2. A means 5u plus 12.5a. And from here you have S1. S2 means you can have distance travelled in 4 seconds. Distance travelled in 4 seconds is S2 is equal to u into 4 ut plus half a into 4 square. This is 4u plus 4 square is 16 by 2a. So this is 4u plus 8a. Therefore distance travelled between 4 and 5 second, 4th and 5th second is S is equal to S1 minus S2. S1 minus S2. You see 5u minus 4u plus 12.5a minus 8a. This is u plus 4.5a. This is the formula for the distance travelled in 4th to 5th second. 4th to 5th second. Have you got this question also? So this is the question related to that number 23. Now I will discuss question. So question number 24 is, question number 24, two stones are thrown vertically upwards simultaneously with their initial velocities u1 and u2 respectively. Prove that the heights reached by them would be in the ratio of u1 square is to u2 square. Assume upward acceleration is minus g and downward acceleration to be plus g. You see, you have initial velocities, you have deceleration, because whenever the body will be going upwards, acceleration will be minus g, means it will be decelerated. Prove that the heights reached by them, you have to find the ratio of their heights. So one thing you know, that at the highest point, yeah, at the maximum height, V is equal to 0. Use this formula. V square is equal to U square minus 2GH for the first stone. First stone. You see V is 0. 0 square. U is U1. U1 square minus 2G H1. From here 2G H1 is equal to U1 square. So H1 is equal to U1 square by 2G. Now for the second stone. For the second stone. 0 square. Initial velocity is U2. So U2 square minus 2G H2. 2G H2 is equal to U2 square. This gives you H2 is equal to U2 square by 2G. You have to find H1 square, H1 by H2. So this is U1 square by 2G divided by this means 2G by U2 square. This is U1 square by U2 square. You have to prove this only. So with this you completed the problems from NCERT problem, exemplar problem books, and now I hope you have learned the first chapter, namely motion. Even if you have any doubt, you can ask the question there on the WhatsApp group. Thank you.